Hi and welcome again. The last video that I made, I talked about fine tuning and we talked about epochs, pruning, and quantization. We also talked about prompt engineering and how, in the domain of cybersecurity, system prompts, user prompts, multi-shot prompts, zero-shot prompts, system roles, and templates can be used for cyber defense or cyber offense. So, in this video, I'll be talking about data processing and also talking about data types and watermarking. So, unfortunately, I'm not able to cover, because of the broad length of this course and the information. My next video will cover retrieval augmented generation RAG, and also I noticed as well I have not covered this NLP. So the structure of this course is kind of should flow in a natural state and natural way. So after today, I will just talk about data processing, the data types, and watermarking. And my next video, I will talk about RAG and also talk about NLP. Alright, so let's get started. Today I'm talking about data processing, right? Data processing involves the conversion of raw data, right? You're converting raw data from its raw state to a clean state before we feed it to the machine learning model or before we feed it into any AI system. Data is the blood of any machine learning pipeline. If the data is corrupted, what it means is that the whole machine learning model is biased or even flawed. So that's why data cleansing involves the removal of duplicates, right? That corrupt the training data process that is being fed into the model. It also involves the handling of missing values, right? For example, there are NaN values in some datasets, NaN, none values, right? Or standardization errors, for example, date, year, month formatting. For example, in Korea, there's different way to write the name format. In the US, there's a different name format system as well. So you need to standardize your data, right? The data that is fed into your company might not be the same that is being shared between the global system or another company. So data standardization is another step for processing or cleaning your data. And then you now enforce business rules as part of your data cleansing step. So we are talking about data cleansing under data processing. Okay, so we are converting raw, noisy, rough data and cleansing it, like cleaning it very well, structuring it well to a clean data before we feed to the model. So this is the essence of data cleansing. So in the exam, you'll be expected to understand how or the components of any data cleansing job usually done by the data engineer. Okay, don't forget that the data engineer is the one who cleanses data. The next step is data verification. Very simple. Data verification talks about, has the data been tampered? We want to verify. There's a concept in cybersecurity, um, trust none, verify all. So we want to verify that the data being fed into the model has not been tampered with, has not been messed around or poisoned with. So that's the goal of verification. We now want to verify, is this data the right data that I need from a machine learning task? For example, you want to train um, maybe a malware prediction or a malware classification um, model, right? What you need exactly is malware data. You want to be sure that the data being fed into the model is not maybe network traffic data, right? Or image data. You want to verify that this data has not been tampered with, right? And so that's the essence and the goal of data verification. Data lineage talks about the full map of the data lifecycle by these people, the data engineer, the machine learning engineer, and the system architect. This is the full journey of data engineers, machine learning engineers, and system architects, right? We want to see from the origin of the data to the transformation logic, the path and flow of data, and then the version of the data, and then the destination of the data, right? It's like the lineage, just like the hereditary of the data, where the data came from, how it's being transformed, where it's gone to, the current version of the data, and then the final destination or the target or the users of this particular data. So this is the full journey and map of data lineage, right? Data lineage and data provenance, right, can seem similar, but as I teach and as I explain, I will also distinguish the difference between the data lineage system or the data lineage in machine learning, right, or machine learning used for cybersecurity, and data provenance. Okay, so for now, let's understand and agree that data lineage is the map of the data's life cycle amongst these technical guys, right? These technical guys, when you're talking, anytime you talk about data lineage, you're talking about a technical journey. So think about a technical journey when you talk about data lineage, okay? Data integrity, right? Cybersecurity, focuses on, integrity, the CIA triad, right? Confidentiality, availability, and integrity, right? When we talk about data integrity, we are looking at the fact that we're looking at assurance, right? We want to assure the users that the data is accurate, right? The data has not been leaked or has not been lost, and also the data has not been corrupted through any kind of form of backdoors, right? So this is the essence of data integrity within the MLOps pipeline, okay? Right? So that's why I also try to capture the difference between data in transit and data at rest. So data in transit means you're moving through something, right? Through a network. While data at rest is data that is stored in drives. Okay? What kind of attack can we witness during data in transit? We can witness man in the middle attack or a sniffing attack, trying to, you know, decipher or find out what kind of data is being moving through that network, right? But data at rest can be a physical theft or stealing of the hard drive or a credential compromise, right? So, what protocols can we use to secure data in transit? Or the essence of all of these is towards data integrity. We want to be sure that the data is accurate, non-corrupt, and has not been lost. So what kind of protocols are we talking about when we talk about data in transit? We're talking about the TLS 1.3, IPsec, SSH, and HTTPS. Okay? But when we talk about data at rest, right, we're talking about data disk encryption, trusted execution environments, and these are like the protocols that help enforce data at rest. When we talk about encryption in transit, we're looking at ASGCM, and we can either choose the 128 or 256-bit version, right? Or we look at AES XTS when we talk about data at rest. Okay, so the full idea of data integrity is to ensure that or have give our users or the whole system or the whole AI system an assurance of data accuracy, assurance against data loss and leaks, and assurance of against corruption or backdoor. So this explains data integrity. We've talked about data integrity. We've talked about data lineage, the full journey. We've talked about data verification. We've talked about data cleansing. Okay. So now we look at data provenance. Remember, I said that the data lineage and the data provenance look similar. But the difference here is that whenever let's make it more simple, right? The data um the data lineage, right? This one talks about technical people. We're looking at the technical data engineers here, right? And system architects. But when we talk about data provenance, right, we are looking at compliance guys, the guys from the compliance team, right, right. So we're looking at tracking the ownership, complete history, and authenticity of the data, right? And the benefits include audit readiness. These are the guys from the audit department, the compliance team, the version control people, right? They want to ensure that you're actually in compliance with data ownership, right? And authenticity of the data. Okay? So the people involved are the compliance officers, the legal teams, and auditors. So this helps gives us a clear distinction, especially for the exams, where you might have cases or situations where you are asked what is the difference between or you're asked to maybe create a scenario or explain or choose between a scenario where you're giving data provenance and um, data what's it called again, data lineage. Okay, so this is well explained. And also we talk about data augmentation. The word augmentation means to add, right? Because something is small. So the goal here is model optimization. The model cannot perform well on limited data. If you have limited data, your model does not perform well, right? So that's why sometimes we experience or we increase our data set size, right? So that the model can generalize or the model can perform optimally. And that's why we need augmentation. Okay? Augmentation is not the same as synthetic data. Synthetic data means you are using a generative AI system to generate entirely new. So here it talks about something entirely new, right? But with augmentation, you have small and you want to make it big, or you have small and you want to increase the size. Okay, this is the difference between augmentation. You're augmenting something and you're making something new from scratch. This has to do with generative AI systems or generative models. Why augmentation has to do with augmentation algorithms, which I'll cover real quick. Okay, so look at augmentation. The original data here is in this shape. Look at the original data of this cat, right? But when we augment the data, we can flip, we can translate, we can turn the resolution or whatever of the outlook of the image, right? We can rotate and we can scale, right, from an original data. But with synthetic data, we are generating entirely new, images or samples for model training. Okay, so augmentation also is not balancing. So some people talk about balance or imbalanced data sets, right? Augmentation first comes and is a step towards data balancing. This one comes first, and then this one comes eventually. Through augmentation, you'll be able to balance your imbalanced data set. So let's look at this GitHub repository to understand some examples of data augmentation. So, augmentation, right, is a public, it has about 15 stars, right? It's a public, uh, is a public repository for generating, um, uh, for augmenting your data set. Okay, so, um, this is the repository, and you can see that the original image here has seen an RGB shift, some saturation here, and some shuffling in this segment, right? And another one just like this, we can blur and manipulate and augment the image so that we'll get the taste that we want before feeding into our model. Very popular library for data augmentation. Okay. Another augmentation method is smooth. I have used this one personally for my research, right? So smooth means synthetic minority oversampling technique. I will explain what smooth actually does. So before, take for example, you have um, a malware sample or a spam data set. We have 90% of the data is spam and 10% is not spam, right? So what we have here, look at this example for example, right? This is the transactions. We have 98%, right? And we have 1%. Very small sample. And using this kind of data, training directly with this kind of data might not lead to a good generalization. And so that's why we need uh, data augmentation. We need to increase this size, this minority size, to be balanced with the credit card data set, right, before training. So I'll show you what happens. So after if we ignore the imbalance, we see an accuracy of 98%, but a recall of 0.9. That means 9%. Very low recall, but very high accuracy. So this shows you something is going wrong. You cannot deploy this kind of model into your maybe AI detection system or your cybersecurity AI model. You cannot deploy this because it's gonna accurately show you, oh, I'm doing well, but the recall in real life scenario is gonna be poor. But after augmentation, what we notice is that we have better performance. So we see here the accuracy is 99 and the recall 99 as well, showing that the model has performed well after smooth. Applying smooth to features X and the Y target data resulted in a new feature and target set which is larger due to the oversampling. The accuracy is 99, the recall is 99. This explains to us the essence of augmentation. Okay? Now we'll talk about structured data. Structured data are data or that is very organized, highly organized data. Right? We already know, oh, clean, and it's easy to feed into traditional machine learning models such as random forest, decision trees, um, um, light gradient boost, right? K nearest neighbor. Oh, these are very simple models, right? Traditional models, right? They don't need excessive high computation or high intelligence compared to what we have today, right? Like large language models, right? So they are usually from CRM databases, very structured, very clean, very sweet, neat. Excel files, already clean and neat, right? SQL databases, right? They are structured data, just as the name sounds. But semi-structured data talks about partial structures, right? Not well structured as we want. We still need to do some modifications, still need to adjust a few things, right? For the semi-structured data. So they have partial structure, they have flexible schema, they're good for APIs, right? And they exist in either JSON format or XML format or CSV format. The JSON format is one way that we usually use to harvest or witness the representation of the input and output of ML models. So, for example, our ML model, the input in a JSON file, the JSON file of an ML model, right? After prediction, we'll have the input, the output. Sorry, excuse me. We have the input, the output, and some other details, some other random details, maybe the model version, the date, the time. These are like random semi-structured data, but it's fairly easy to understand. You might still need to remove some things or add some things from the data structure. Okay, so they are not fully organized, just as the name sounds, right? And that's why we call them semi-structured data. For the unstructured data, notoriously very difficult. If you worked with this kind of data before, you understand what I'm saying. You need to do a lot of processing. You need to be careful. You need to structure your data very well. A good example in the domain of cybersecurity is pickup files. So pickup files can be very unstructured. You need to structure them or pass them through like, a flow meter tool that extracts the statistical features of the network traffic, right? They're in PDF formats. Some PDFs, if you feed them to the model does not recognize maybe handwriting, for example. Some handwritings can be very, very noisy. right, and difficult to understand. Images as well can be unstructured, and audio and video files can be very, very unstructured, right? So that's why we have or we deal with unstructured data. And once you have this kind of data, if you're actually being you don't need some of them might also perform well if you use a big or a strong algorithm or a strong machine learning model. It is very absurd to use an unstructured data with with a very traditional machine learning algorithm. It doesn't do well. It can never do well because the intelligence or the properties of those models cannot handle the data structure. Okay, so the next thing we talk about is watermarking, right? Watermarking talks about copyright. You're screaming copyright, copyright signals, intellectual property. So what we see these days is that some AI models are trying to ensure that they watermark part of their AI system so that competitors cannot just take full advantage of their R&D strength and effort. So that's why they watermark their products. For example, you're a music producer. You want to watermark your music so that someone does not just clone or steal your intellectual property. So the essence of watermarking here, as the exam will also ask some questions about that, is to ensure transparent use of the AI models themselves, right? And then what makes a good watermark? Number one, it must be robust and resistant to, detection, right? Or bypass. What is the essence of watermarking something that can easily be removed? So your watermark or your watermark technology must be very robust. Second one is invincibility. If they can see your watermark, they can easily extract or take it out or bypass your watermark, right? It must be invincible. It must be like a honeypot. You just need to, people will take it for granted and then eventually fall into the trap of copyright fines or regulations or whatever it is. You need to protect yourself invincibly, okay? And then they must have the capacity to store information. That you watermark something does not make the thing useless. If I watermark this particular video that I'm making right now, and you cannot understand the video, or the video cannot be fed into a machine learning model, then it's useless. So that's why the watermark file or source image or whatever it is or data must have the capacity to store information, be invincible, and be robust. Okay, so this is like a summarized overview of what matter of what we expect from the exams when we talk about watermarking. Okay, so what is the taxonomy of watermarking, right? I got this from Nisha, and it breaks down according to text and image, right? For textual methods, we can either watermark with AI. So AI algorithms can essentially help you to create a good watermark for your textual data. So you can change the format, right? By adjusting some important formats of the data, you can watermark your text data. So lexical substitution, you can substitute lexical structures, right, within the text and make it your own form of watermarking. And then syntactic modification, right, can also be a good method. And logic-based method is like, AI models or especially large language models, right, have logics. For example, the confidence that when I say something, I am going to bed, right? Maybe the next word is tonight, right? So the logic distribution of saying tonight is what um, people usually can extract from open weight large language models. If an attacker has the logic distributions, he can craft and change the model, or distill the model and clone your model. So that's why people uh, have to watermark their large language models. So you can watermark your the logics to prevent attackers from harvesting those logics. The mathematical brain of the large language model, right? So that's why we have logic-based uh, watermarking. In the coming videos of this series, I will explain uh, the essence and the structure and the taxonomy of unauthorized distillation attacks. I will explain all of that and show like how some companies or some AI providers or whatever, steal proprietary knowledge of another model by simply cloning logics. Okay. And then token-based sampling is also another method for watermarking text. On the image side, we also have spatial domain technique, transform-based technique, and deep learning-based technique. We don't expect this in the exam. We just expect you to know, or we are expected to have the basic idea of what watermarking essentially does for the machine learning operation systems, or the machine learning based cybersecurity domain, or how much watermark what watermarking contributes to the whole SecAI environment. Okay, so that's it. Up next, very interesting. I'll be talking about RAG. So get ready for RAG. Retrieval augmented generation. RAG is is a very interesting topic you wouldn't want to miss. You wouldn't want to miss these explanations and some questions that we'll be going going through as well. And then eventually I will cover the natural language processing, and we are slowly completing part one of the SecAI exam objective. Thank you very much for watching.